All right, everyone, get ready for a deep dive.
A deep dive.
Yeah, we're going under the hood.
Under the hood, huh?
That's right, of JavaScript today, into the world of memory management and garbage collection.
Yeah, memory management. That's a good one.
I know, right? It's one of those topics.
It's kind of a mystery to a lot of folks.
But it's so important.
Oh, it's crucial, especially if you're working with,
large data sets.
Big data sets, complex web apps.
If you've ever been on a web page and it just gets slower,
oh, yeah.
the longer you're on it.
Oh, the worst.
Yeah.
That's probably...
It's a memory leak.
A memory leak.
Yeah. And that's why we're here today.
And it's funny because JavaScript kind of manages memory.
It does, yeah.
Automatically. But we still have to write code.
Well, you got to play nice with the system, right?
Right, exactly.
It's like having a robot cleaner. It does its thing. You got to make sure you're not leaving. Like a bunch of stuff, obstacles in its way.
Exactly. You got to work with it.
And understanding this is like
a secret weapon, I think, for developers.
It is.
I mean, you can build these really high-performing apps that people will love.
So let's start with the basics.
The basics, okay.
So where does this all happen, this memory stuff in JavaScript?
So picture this, right? There's this place called the heap.
The heap.
Yeah, and it's this this area of memory where JavaScript is storing everything.
Everything.
Objects, functions, all the good stuff, the data.
So it's like a big container.
It is. It's a big container, dynamically allocated.
Dynamically, yeah.
Now there's also the stack.
Okay.
But we're not gonna talk too much about that.
Yeah.
For this deep dive.
Focus on the heap.
We're focusing on the heap. That's where the action is.
That's where it's at.
Yeah.
Now we've got all these objects, functions, all this data in the heap. How does JavaScript know, like, how long they're supposed to stay there?
Okay, well, that's where this whole idea of variable lifetime comes in.
Okay.
And scope.
Scope, right?
So scope is like a set of rules.
I always think of it as like
what?
Like a bouncer at a club.
Okay. Yeah, okay.
Some variables can get in.
They have access.
Some can't.
Yeah, exactly. And then you got these closures.
Oh, closures.
That's always fun, right?
Yeah. Can you remind me again how?
Yeah, so closures are like
what they are?
Little backpacks for your functions.
Backpacks?
Yeah, they let functions remember. Yeah. Variables, even after the function's done its thing.
Oh, okay.
So it's kind of like...
So that's how they can cause problems with memory, right?
Well, that's where it gets a little tricky.
Okay.
Because... if those closures are holding on to stuff, it can stay in memory longer than you think.
Oh, okay.
So let me give you an example. Let's say you have this function that makes a counter.
All right.
Starts at 0, right? Each time you call it, it goes up by 1.
Pretty basic stuff.
Yeah, pretty standard.
Right.
But here's the thing. With the closure, it's still holding on to that count variable
even though the function
after the function's done. So it's still using memory.
It's still there lurking in the shadows.
Okay, so this is where our garbage collector comes in.
Our hero.
Right.
The garbage collector,
Because we've got all this stuff being created, variables, functions, objects. It's a mess.
How does JavaScript keep things...
How does it not just explode?
Yeah, from just taking up all the memory.
Well, the garbage collector, it's like a cleanup crew, Okay. It runs in the background.
Constantly looking for stuff to throw away.
Looking for what you don't need anymore.
Okay.
So it keeps things nice and tidy.
So how does it know what to throw away?
It's not random. It's not just like flipping a coin.
Yeah.
It uses these algorithms to figure out what's not being used.
Okay, and what are?
There are two main ones. Mark and sweep.
Mark and sweep.
And reference counting.
Okay, let's break those down.
All right, let's do it.
So mark and sweep.
Okay, so imagine this. You have this giant e-commerce site.
Oh.
Thousands of products, right?
Thousands.
And when someone visits your site,
right,
they're only looking at a few things at a time.
Of course.
Mark and sweep, it's like a little robot. Goes through the heap.
Okay.
Marking everything that's actually in use.
Okay.
And then anything that's not marked.
Gone.
It gets swept away.
So it's basically figuring out what's still alive.
Exactly. What's alive?
Yeah, what's dead?
And what's dead weight.
I like that.
Gets out of there.
Okay, so what about reference counting?
Okay, reference counting is like it's like a
borrowing system, right?
Okay.
Each object, it's like it has this little
counter,
yeah. Keeps track of how many other things are using it.
So if nobody's using it,
if it hits 0, gone.
Garbage collected.
Garbage collect.
Okay, so it's all about the connections.
Connections, yeah.
And once an object's not connected...
No connections. See you later.
Exactly.
So this is great. We've got this awesome garbage collection
That's pretty slick.
system in JavaScript.
Yeah.
But even with all this...
There can be problems.
Yeah. And that brings us to our next topic. Memory leaks.
Ah, memory leaks.
The dreaded...
The silent killer.
Memory leaks. So why should we be worried about these? Why are they such a big deal?
Well, think of it like this, right? You got a dripping faucet.
Okay.
At first...
Not a big deal.
It's just a little drip, drip, drip.
Yeah.
But over time...
It adds up.
It can waste a ton of water.
Right, right.
And that's exactly what memory leaks do to your app.
To your application.
They eat up resources.
So it's not just about being tidy.
It's not just about being tidy, no.
It's about performance.
Users.
Keeping your users happy.
Happy.
Yeah, because who wants to use a slow, laggy app?
Nobody.
No one. No one.
So what are some of the things? Okay, so the usual suspects.
Yeah, that cause
memory leaks.
These memory leaks.
Well, you mentioned global variables earlier.
Really?
Global variables, they're classic. They're like... The
bad boys of memory management.
Right.
Because
they just hang around.
They hang around forever.
Forever. They never go out of scope. Unless you explicitly tell them to go away.
Right.
They're just there.
It's like
leaving the lights on.
In an empty room.
Yeah, in a room you're not even using.
Okay, so global variables.
Global variables, use them sparingly.
Use them sparingly.
And clean up after yourself.
And clean up.
Yeah.
What else should we be on the lookout for?
Okay, so another sneaky one is event listeners.
Event listeners, right?
Yeah, these are crucial.
Absolutely.
For interactive website.
Yeah, you need them.
You gotta have them.
For everything.
But if you forget to remove them, when you're done with them,
that's a problem.
They can hold on to memory like a dog with a bone.
Like, for example.
Okay, yeah.
If you have an
image. Like an image carousel, right?
Carousel, yeah.
So each image, it might have an event listener on it. So you can zoom in or pan around.
But if you move away from that carousel.
And you don't remove those listeners.
Oh.
Memory leak city?
It's like forgetting to cancel a subscription.
Yeah, yeah.
You're still paying for it.
You keep getting charged.
Even though you're not using it.
Even though you're not using it.
Yeah. And those forgotten listeners, they add up, especially as your app gets more complex.
Yeah, so we've got global variables.
Global variables.
Event listeners.
What about those closures? Those backpacks.
Yeah.
How do they turn into memory leak villains?
Ah, yes, the closures.
They're closures.
Remember how they can capture variables?
Yeah, yeah.
Well, if those variables are big, like big objects, lots of data, they can prevent those objects from being garbage collected.
Even if
the function's not doing anything anymore.
Right.
So it's like packing your entire house.
For
a weekend trip.
Yeah.
You're taking way more than you need.
Way too much.
Yeah, and it's just going to weigh you down.
Okay, so for example.
So let's say you got a closure.
Yeah.
And it's holding on to this giant image.
A giant image.
Even if you only need a tiny part of it, that whole image is still in memory.
Because the closure.
Because the closure's guy.
It's holding on to it.
Yeah.
Okay. I'm seeing a pattern here.
Oh, yeah.
It seems like a lot of these memory leaks come down to just holding on to stuff.
Holding on to stuff you don't need?
For too long.
For way too long.
Right.
Exactly. And that's what we're going to tackle next.
Okay.
We're going to talk about some best practices.
Best practices.
To prevent these issues.
To keep our memory usage in check.
Keep your memory nice and lean.
All right, let's hear it. What are the tips from the JavaScript masters?
Okay, so first up, we got to talk about local variables.
Local variables.
These are your friends.
Okay.
Unlike those pesky global variables,
yeah.
Local variables, they have a short lifespan.
A short lifespan.
They live fast, die young.
They're like rock stars.
You're like, yeah, they burn bright, then they're gone.
Okay.
And that's a good thing for memory.
So they're only accessible.
Only in their little area.
Yeah.
Their function, their block of code.
And once that's done,
poof.
Gone.
Gone.
Garbage collected.
Oh, exactly.
Okay, so contain those variables.
Contain them.
Keep them on a short leash.
Short leash.
All right, what else?
Okay, next up, we got to be diligent about removing those event listeners.
You're event listeners, right?
Right when we're done with them. Don't just leave them hanging around.
Right.
It's like good code hygiene, you know?
Code hygiene, I like that.
Yeah, clean up after yourself.
So give your event listeners...
Give them an off switch.
An off switch, yeah.
And most frameworks, they make this pretty easy.
They do, yeah.
There are tools for this.
So learn those tools.
Learn those tools, yeah.
Okay, what about closures? Those backpacks.
Ah, yes, the closures.
Any tips for those?
Think carefully about what you're packing in those backpacks.
Okay, yeah.
Do you really need to take everything?
Right.
Or can you just take the essentials?
The essentials, yeah.
Sometimes a little refactoring can go a long way.
To lighten the load.
To lighten the load, exactly.
Okay, so be mindful of what you're capturing.
Be mindful, yeah.
Don't pack more than you need.
Don't overpack.
Okay, got it.
Now, another thing to consider is your data structures.
Data structures.
Yeah, so sometimes you might be using an array.
Right.
When a map or a set would be way more efficient.
Right, and especially if you're dealing with...
Especially with big data.
Huge data sets.
Yeah, you want to choose the right tool for the job.
Right.
It's like using a hammer to screw in a screw.
Yeah, or a screwdriver to hammer a nail.
Exactly. It's not going to work very well.
Okay, so we're being careful.
We're being careful.
We're writing good code.
We're following best practices.
What's something?
Sometimes those memory leaks...
They still sneak in.
They can be sneaky little devils.
They can.
They can.
And that's where our debugging tools come in.
Ah, yes. Our superhero tools.
Right. And we talked about Chrome DevTools.
Chrome DevTools.
Earlier. It's a game changer.
So what are some of the tools that we have?
Okay, so one of the most powerful tools
Yeah.
is the ability to take heap snapshots.
Heap snapshots, right?
Remember that analogy of taking a photograph?
Yeah.
Of your memory?
Of the memory.
That's exactly what a heap snapshot is.
Okay.
It gives you this detailed breakdown of everything. Of everything.
That's in the heap.
Okay.
All the objects, their sizes.
So we can see who's holding on to what.
Exactly.
Look.
You can see the references.
The connections.
The connections between
And
it.
you can see if anything's getting too big.
You can see if there are any memory hogs.
Right.
And the cool thing is you can take snapshots at different points in time.
Okay.
And compare them.
So we can see how things are changing.
You can see what's growing, what's not being released.
It's like a memory time machine.
It is. It's like a memory detective tool.
I like that.
Yeah, you can track down those memory leaks.
So heap snapshots.
Heap snapshots.
Very powerful.
Very powerful. And then you got the timeline tool.
The timeline tool.
Yeah, this gives you like a
movie.
Of your memory usage over time.
Over time, so we can see how it changes.
You can see how different actions, like clicking a button.
Or loading a page.
Yeah. Affect memory.
So we can watch it in action.
You can watch it all happen in real time.
Okay, and then there's the allocation timeline.
Yes, the allocation timeline.
Right. This one's a
bit more granular.
More detailed.
Yeah, it shows you exactly when and where memory is being allocated in your code.
It's like having...
It's like an X-ray vision.
X-ray vision for your memory.
For your memory, exactly.
Wow. So that's a lot of powerful tools.
It is.
But let's be honest, sometimes you open up DevTools, you see all this information.
It can be overwhelming.
It can
be a bit much.
So where do we even begin?
Okay, so my advice is start with the basics.
Okay.
Don't try to understand everything all at once.
Right.
Focus on one thing at a time.
Okay.
And use the tools strategically.
Strategically, yeah.
So, for example, if you think you have a memory leak, look for objects that are growing out of control.
Okay.
Or look for patterns in the timeline.
Patterns, yeah.
Like, does a certain action always cause a spike in memory usage?
So look for those red flags.
Look for those red flags.
And then use the tools.
Use the tools to investigate.
To dive deeper.
Exactly.
Okay, so it's all about experimentation.
Experimentation.
Right.
Yeah.
Trying things out.
See what happens.
Seeing what happens.
And don't be afraid to comment out code.
Right.
Just to see how it affects memory. Okay, so
the more you
use these tools,
the more comfortable we'll get.
The more comfortable you'll get.
With them.
And the better you'll understand how memory works in JavaScript.
It's like learning a new language.
It is.
Yeah.
It takes time and practice.
But it's so valuable.
But it's so worth it.
Yeah, it is.
It's like a superpower for a JavaScript developer.
So we've talked about a lot, but there's one more thing.
Oh, there's more.
There's one more thing.
Okay, hit me with it.
That we need to talk about.
All right.
When it comes to memory management.
Okay, I'm ready.
And that is how we can actually help JavaScript out.
Help JavaScript out.
Yeah, how we can
optimize memory usage.
Okay, I'm intrigued.
And make our applications even more performant.
Even more performant. Tell me more.
Yeah. So we'll get into that.
All right, let's do it.
In our next part,
I'm excited.
This deep dive.
Let's go.
Into JavaScript memory management.
All right. So it's not just about, keeping your code neat and tidy.
Yeah, it's about...
It's about performance, right? It's about making sure your app runs smoothly.
And keeping our users happy.
Exactly. Happy users. That's what we want.
So what are some of the things?
Let's talk about the usual suspects.
Yeah, that cause these memory leaks.
The memory leak culprits, right?
Yeah.
We talked about global variables earlier.
Right.
Those are a big one.
Yeah, because they just kind of...
You just hang out.
They stick around forever.
Forever. Unless you explicitly tell them to scram.
Right.
They're there, taking up space.
It's like leaving the lights on.
In an empty room.
Exactly. Wasteful.
Okay, so global variables.
Global variables, watch out for those.
Use them sparingly.
Sparingly, yeah.
What else should we be on the lookout for?
Okay, another sneaky one. Event listeners.
Event listeners, right?
Yeah, we need those for interactivity.
Absolutely, yeah. You need them for everything.
But if you forget to remove them when you're done, they can really hold on to memory.
Like, for example, like if you have an image.
Oh, like an image carousel on a website.
Carousel, yeah. And each image
has an event listener, so you can, like, zoom in or pan around.
Yeah, but if you navigate away from that carousel...
Those listeners are still there.
Well, that's bad.
Memory leak waiting to happen.
Yeah, so it's like forgetting to cancel a subscription.
Exactly. You're still getting charged.
You're still paying for it.
Even though you're not using it anymore.
Right.
And these forgotten listeners, they can really add up.
Especially if you have a complex app.
Oh, yeah, especially as your application grows.
Right. So we've got global variables. We've got event listeners.
Right.
What about closures? Those backpacks we were talking about.
Yeah.
How did those turn into memory leak villains?
Ah, yes, the closures. Remember how they can capture variables?
Yeah, yeah.
Well, if those variables are like really big objects or complex data structures, they can prevent those objects from being garbage collected. Even if the function's not even being used anymore.
Oh, wow.
It's like packing your entire house for a weekend trip.
Way too much stuff.
Way too much. You don't need all that.
Okay, so for example...
Let's say you have a closure that's holding on to a giant image file.
A giant image file. Okay.
Even if you only need a small part of it,
right,
that whole image is still sitting there in memory.
Because the closure's holding on to it.
Exactly.
Okay, so I'm seeing a theme here.
Oh, yeah. What's the theme?
It seems like a lot of these memory leaks boil down to just holding on to stuff for too long.
Holding on to stuff you don't need anymore. That's it.
Right.
Exactly.
So what can we do about that? What are some best practices to avoid these pitfalls?
Okay, so let's talk about some best practices.
Okay, let's hear it.
First up, local variables. Those are your friends.
Local variables.
Use those whenever you can. Unlike those pesky global variables.
Yeah.
Local variables, they have a short lifespan.
Okay, that's good.
They only exist within their little function or block of code.
Right, they're contained.
Exactly. And once that function's done, poof, they're gone.
Garbage collected.
Garbage collected, out of there.
So keep those variables contained. Contained, yeah. Don't let them roam free.
Okay, what else?
Next up, we got to be really diligent about removing those event listeners. Event listeners, yeah. When we're done with them. Don't just leave them hanging around.
Right, it's like good code hygiene.
Exactly. Clean up after yourself. Make sure those listeners have a clear off switch.
An off switch, I like that.
And most frameworks, they make this pretty easy.
You do, yeah. They have built-in tools for managing event listeners.
So learn those tools.
Tools, yeah.
Okay, what about closures? Any tips for those backpacks?
Ah, the closures. Think carefully about what you're packing in there.
Okay.
Do you really need to take that whole giant image?
Right.
Or can you just take a small piece of it?
The essentials.
Exactly.
Yeah.
Sometimes a little refactoring can save you a lot of memory.
So be mindful of what you're capturing.
Be mindful. Yeah, don't overpack those backpacks.
Okay, got it.
Now, another thing to consider, and this is a bit more advanced, is using weak references.
Weak references.
Yeah, these are special types of references that allow objects to be garbage collected. Even if there's still a reference pointing to them.
So it's like a looser grip.
Exactly, like a loose grip. If the garbage collector needs it, it can take it.
Okay, so strong references, those are the ones that prevent garbage collection.
Right. Strong references, they hold on tight.
But weak references?
Weak references, they let go.
They let go.
When they need to.
Okay, so those are useful for certain situations.
Yeah, especially when you're dealing with large objects or data structures.
Okay, so it sounds like these techniques, these weak references and the other best practices, they add another level of finesse.
They do.
To our memory management skill.
It's like taking it to the next level.
Right, it's not just about avoiding the big mistakes.
Right, it's about optimizing, it's about making your code as efficient as possible.
So even with all these best practices, sometimes those memory leaks,
Oh, they can still happen.
they still manage to sneak in.
They can be sneaky,
Right.
like little ninjas.
And that's where our debugging tools
Oh, yes, our trusty tools.
come handy.
Chrome DevTools to the rescue.
So what are some of the tools that we have?
Okay, so one of the most powerful tools is the heap snapshot.
Heap snapshot, right?
Remember that analogy of taking a picture of your memory?
Yeah.
That's exactly what it does.
Okay.
It gives you this detailed breakdown of all the objects in the heap.
So we can see who's holding on to what.
Exactly. You can see all the references.
The connections.
And you can see if anything is getting too big.
Right, if there are any memory hogs.
Yeah, and you can take multiple snapshots over time and compare them.
So we can see how things are changing.
You can see what's growing, what's not being released.
It's like a memory time machine.
It is. It's like a detective tool for your memory.
Okay, that's cool.
And then you have the timeline tool.
The timeline tool, right.
This one gives you a visual representation of your memory usage over time.
So we can see how different actions?
Yeah, like clicking a button, loading a page.
Affect memory.
You can see how it all plays out.
Wow, so we can watch it in action.
You can watch it happen in real time.
Okay, and then there's the allocation timeline.
Yes, the allocation timeline. This one's a bit more in-depth.
More granular, yeah.
Yeah, it shows you exactly when and where memory is being allocated in your code.
So it's like
It's like X-ray vision for your memory.
X-ray vision.
You can see right through it.
That's amazing.
Yeah.
So we've got all these powerful tools, but sometimes
it can be a bit overwhelming.
it can be, yeah. All that information.
So where do we even begin? How do we use these tools effectively?
All right, so we were talking about how we can help JavaScript out.
Yeah, how we can optimize
that memory usage.
make things even
smoother, faster.
more performant.
More performant, yeah. So one cool technique
Okay.
is called object pooling.
Object pooling.
Yeah, have you heard of this one?
I've heard of it. I don't really know what it is.
Okay, so imagine you have a game
Okay.
and you're creating all these enemies,
Right.
and then they get destroyed, you create more.
Classic game stuff.
Right. So instead of
Constantly creating new objects.
creating and destroying, yeah.
Yeah.
You create a pool of objects ahead of time.
So you have them ready to go.
They're just sitting there, waiting.
Okay.
And then when you need a new enemy, you just grab one from the pool.
You grab one from the pool, use it, and then when you're done,
You put it back.
you put it back in the pool.
So it's like recycling.
It's like recycling for objects.
Instead of throwing them away.
Exactly. You're reusing them.
And that saves memory.
It saves memory. It saves time. It makes things run smoother.
Because you're not constantly creating and destroying.
Exactly. Less work for the garbage collector.
Okay, that makes sense.
It's a really powerful technique, especially for games or anything that's performance critical.
Right, where you're doing a lot of
object creation and destruction.
Yeah, okay, cool. Are there any other optimization techniques that we should be aware of?
Yeah, so another one, this is a little more advanced.
Okay.
It's called using weak references.
Weak references.
Yeah, so
we have strong references and then we have weak references.
Right, strong references. They're like, I'm not letting go of this object.
They hold on tight.
They hold on tight, but weak references, they're a little more chill.
They're like, if the garbage collector needs this, take it. Go ahead and take it. I'm not going to stop you.
So it's like a loose grip.
Exactly. A loose grip, yeah.
Okay.
So if there's no other strong references to that object,
Right.
the garbage collector can still come in and sweep it away.
Even if there's a weak reference pointing to it.
Even if there's a weak reference, yeah.
Okay, so that's useful for...
It's useful for certain situations.
Or you might want to hold on to a reference.
Right. You want to keep track of it.
But you don't want to prevent it from
being garbage collected.
Right.
If it's not needed anymore.
Okay, so these techniques, these weak references,
yeah,
object pooling, all this stuff.
It's all about optimizing.
It's like
taking our memory management skills to the next level.
Yeah, it's like we're playing.
Playing in the big leagues now.
In the big leagues.
Yeah, we're not just,
avoiding mistakes.
Yeah, we're
actively
making things better, improving performance. Okay. So to kind of wrap things up here.
All right, let's wrap it up.
What are the key takeaways? What do you really want our listeners to walk away with from this deep dive into JavaScript memory management?
Okay, so the biggest takeaway is don't be afraid of memory management.
Don't be scared of it.
Don't be scared. It's not this big, scary monster.
Yeah.
Once you understand it.
It's
actually pretty cool.
And empowering.
It's empowering, yeah. Because you can really take control of your code.
Make it run.
Make it run the way you want it to.
Smoothly,
efficiently, no memory leaks.
Yeah, so it's all about understanding the rules of the game.
Right. Understand the rule.
And then playing strategically.
Play strategically, exactly. So we've got JavaScript doing its thing.
It's doing its best.
But we need to work with it.
We got to work with it. We got to write code that plays nice.
And understanding things like variable lifetime.
Variable lifetime, scope, closures,
all that stuff.
Garbage collection.
Yeah.
That's how we can prevent.
That's how you prevent those memory leaks.
And make our applications.
Make them sing, make them fast, make them efficient.
And don't forget about those tools.
Oh, yeah, the tools.
Chrome DevTools.
Chrome DevTools. It's your best friend.
It is. It is.
Use it, explore it, learn it.
It's a superpower.
It's a superpower for JavaScript developers.
So, to our listeners out there.
Yeah, to all the JavaScript enthusiasts out there.
We encourage you.
To
keep exploring these concepts.
Dive deeper, learn more, practice.
Play around with Chrome DevTools.
Yeah, break some stuff, fix some stuff.
And really challenge yourself to think about the memory implications.
The memory implications, yeah.
Of your code.
Because it matters.
It does. It does.
All right, I think that's a wrap.
That's a wrap for today's deep dive.
Another deep dive in the books.
Into JavaScript memory management.
We covered a lot of ground.
We did.
But it's all good stuff.
It is. It is. And to our listeners, thank you so much for joining us.
Thanks for listening, everyone.
Until next time, happy coding.
Happy coding, and may your code be always
memory efficient,
and blazing fast.
See you next time.
See ya.